Look at your notes. This is section 2.6. These are the business application notes. So like I was saying earlier, a lot of you are going to have to take a business calculus class, and that business calculus has to do with maximizing your profits, maximizing your revenues, while minimizing the cost to the company. So we're going to be looking at how calculus helps us to come up with those values that are going to do that maximizing or minimizing. So whenever we're talking about the business applications, X is always going to represent the number of units that we produce or sell. P, lowercase p, is going to be the price per unit. The price has to be based on the demand. Like, we can't go out and try to sell graphing calculators for $5,000. It's not going to work. People aren't going to be willing to pay that much money for them. So it has to be, the price has to be set so that you can still make a profit. So a lot of times in these business applications, we're trying to find out what should the price be in order to maximize that profit. R is the revenue from selling X units. So for example, let's take the graphing calculator example. We can sell those for probably $100. That's what the new TIs are going for. And if we sell 1,000 of those, it would be 1,000 times 100. That would be what our revenue would be. Revenue is the amount of money that we have coming in. C is the cost of producing X units. So our cost to produce those units, it probably only costs Texas Instruments. What do you guys think? How much do you think it costs them to make a calculator? Probably, I'd say $12 or $15. The markup's huge on that. So we would have to do, to find the profit, let's go down here to profit now. The profit would be actually the revenue, which was up here, the X times P, minus that cost. So if the cost is $15 for them to make the calculator, and they make 1,000, that's $15,000. So we would have to do X times P, the number of units, times the price minus the cost. So once again, C bar, back up here, this is going to be the average cost per unit, because C tells us the total cost of producing the unit. So if I want to find out the cost per unit, like if they say, oh, we made 1 million of these TI calculators and it cost us 12 million. Well, if I want to find the cost for 1 unit, I would do the 12 million divided by, wait a minute, the number of units, right? So that would tell us what the average cost for 1 unit would be. And then if a company just wants to break even, maybe it's their first year and they just want to break even, well then they may want to know for what number of units will the revenue equal the cost. But eventually they want to start making a profit, so they will want to see that that revenue is more than the cost is to their company. Okay, so the next thing are marginals, and this is where the calculus comes in. The marginal revenue is the extra revenue from selling 1 additional unit. So we might have a function that represents our revenue, and as we sell 1 additional unit, that revenue is going to rise. dCdx is going to be the marginal cost. This is the extra cost of producing 1 additional unit. dPdx is going to be the marginal profit, the extra profit from selling 1 additional unit. So we have these functions now that would represent our profit, our revenue, etc. And we will be thinking about marginals when we get into this. So let's look at an example so this all kind of comes together for you. So the price, meaning the demand of a function, is P equals 8 plus 10 over the cube root of X. Find the revenue function. Well, look back up. This is our price we're going to charge. We want to find the revenue function. So to find revenue, we have to take that price and multiply it by what? The number of units, which is going to be X. So our revenue function then is going to be X times P. So the revenue is going to be X times 8 plus 10X to the negative 1/3. All I did was I brought this up to the top so it would become a negative exponent. So now distributing that, R is going to be 8X plus, what do I get if I do X times 10X to the negative 1/3? What do you do with your exponents when your bases are alike? Add them. So what's it going to be? 10x to the 2/3. So there is our revenue function simplified. Now we're asked to find the marginal revenue. With the marginals, what does that mean we're going to do? Just take the, what does this mean? dr dx. Derivative, right. So we're just going to take the derivative. So the marginal revenue function, dr dx, is going to be, the derivative of r is dr dx, the derivative of 8x is 8. Derivative here, I have to do 10 times 2/3, that's 20/3 x, subtract 1. So there would be the marginal revenue function. We're back to taking the derivative with respect to x, not with respect to t. Okay? And then in part C, find the approximate extra revenue from selling one additional item when 1,000 items are sold. Well, I'm just going to call this r prime. That means to do r prime of 1,000. So we're going to take this revenue function and plug in 1,000. See how I rewrote it even again? It's 20/3. This goes to the bottom, and remember how this tells us the root. So to the negative 1/3 is the same thing as the cube root of 1,000. You have to use a calculator on this. So we're just going to type it in, 8 plus 20 divided by parentheses 3, go under math to get cube root of 1,000. Okay, look at how I had to type this in. I had to do 3 times the cube root of 1,000, so I needed that all to be in parentheses. And we get 8.67. We're talking about money. So this r prime then is going to be $8.67. So that means if we go from selling 1,000 to 1,001 items, our extra revenue is going to be $8.67. What about when 2,000 items are sold? So we're going to do r prime of 2,000. Same thing, 8 plus 20 over 3 cube root of 2,000. So just, I can even just keep this same thing in here. Watch this, guys. I don't need to retype it. I'm just going to do second enter, and that's going to give me the same function again, and I'm just going to change my 1,000 to 2,000. Don't retype it. $8.53. Okay? So if we go from 2,000 to 2,001, that's how much more money we're going to bring in. It's not profit, it's revenue. Revenue is just the money that we bring in, not even thinking about what the cost is. All right, let's keep going. The cost function to produce X t-shirts is given as 320 plus 2.5 radical X. Find the marginal cost function. What do we do with our function that we're given to find the marginal? It's just the derivative, right? So to find the marginal cost, I'm going to call the derivative of C, I can call it dc dx. I can also call it C prime. Let's go ahead and call it C prime. So the derivative of 320, what is it? 0. I might want to think of this as 2.5x to the 1/2 so that I can take the derivative more easily. So now I can do 2.5 times 1/2. What is that? 1.25x. And then we have to subtract 1 from the exponent, and that's going to put us at negative 1/2. That's all we have to do for the marginal cost function. I might want to rewrite it and get rid of the negative exponent. Maybe write it like this. If we're going to be substituting in, it's easier to write it like that. Find the approximate extra cost to produce one additional t-shirt when x equals 200 and x equals 300. Well, it's asking us extra cost just means the same thing as marginal. So I would use C prime of 200, and that's 1.25 over the square root of 200. That's one thing I'm going to do. So go to your calculator. And I get that, 0.08. So it's going to cost an additional 8 cents. And you're going to see that sometimes the cost is pretty high and sometimes it's low. When a business gets started, their startup cost might be pretty significant. They may have to buy a warehouse, they purchase equipment, so their cost is originally pretty high. But then as they get going, the additional cost to produce something is actually very low. They already have bought the material, they already have most of what they need. So that's why you're going to see these really low values sometimes on these cost functions. C prime of 300, I'm not going to bother even typing it in. I'm going to do my second enter, and I'm going to change my 200 to 300. And I get 0.07. So just 7 cents. Okay? So not much more to produce the one additional. Okay, switching to a different problem now. A manufacturing company finds that its product has a demand function of, let's miss typo there, and a cost function of C equals 18 plus 15x. Find the profit function. Oh, we don't have the demand function. Darn. Let's put one in here. Okay. I wonder how that got deleted. Okay, well, let's just make one up here. Let's do that our P is going to be 300x plus 150. That's our demand function. That's a lowercase p. Okay, so we have a demand function and a cost function given. Find the profit function. This is my price. So I have to find that in order to find the profit, it has to be revenue minus cost. This is just my price. How am I going to find my revenue? What do I have to do to this price? Multiply it by X, right. If I'm selling my calculators again, and I'm selling them for $100, if I sell 20 of them, it's 20 times 100. So on this one, here's my price function. So my revenue then is going to be X times P, and then I have to do minus my cost, and I have to be careful that I do minus the entire cost. I can't just subtract the 18, I have to subtract 18 and 15x. So now our profit function is going to be 300x squared plus 150x minus 18 minus 15x. That's going to give us 300x squared plus 135x minus 18. That's our profit function. Find the marginal profit function for the item. What do I do to the profit function to find the marginal? What do we do, guys? Everybody should know this. Derivative. So P prime of x, or do P dx if you prefer, is going to be 300 times 2, which is 600x, plus 135. And now it's just a matter of finishing. Find the marginal profit when 500 units are produced. So P prime of 500 is going to be 600 times 500 plus 135. That gives us $300,135. And then if we're going to do 3,000, now if you're going to do this 3,000, I just want to show you here, I can do my second entry, but I'm going to change 500 to 3,000, so I have to insert another digit. So you're going to have to do second. So to do that, I have to do second delete. So I do second delete, and then I push the number I want, 3, and then it's 3,000. And then I'm just going to arrow over and arrow back. It'll take a little practice to get used to that, and that gives me 1,800,135. And then 6,000. And that's pretty easy to do. Second entry, and then change our 3,000 to 6,000. And 3,600,135. So this could be something like cars or something where we're making a lot more money. That's actually not very realistic, because a marginal would mean that to go from 6,000 to 6,001, we would be making that much more of a profit. But you understand that this would have to be like $1 million houses or something for this to really happen. Okay? All right. You got the idea, though, of how the process goes? Okay. So you guys have your worksheet. You'll need to work on that. Look back at your notes if needed. Yep.